All right, so our first major lesson in chemistry is going to be about significant figures and what we can do with them. So, what we're going to do at this point is we're going to start talking about how to identify significant figures in chemistry class. And so, there's three basic rules that I want to take a minute or so to go over, and then we're going to do a little bit of practice. So, the first basic rule says, let's see. It says all zero or all non-zero digits and any zeros contained between non-zero digits are significant. So what that means is that any number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, any of the, or not 10, actually, let's get rid of that. Any of these numbers, 1, 2, 3, 4, 5, 6, 7, 8, or 9, are significant when they show up in a number. So in the case of our first example over here, we have a 3, a 4, and a 2. So all three of those numbers are significant. So we would say that this number has 3 sig figs. Okay. And so if we look at this next number over here, I have a 9, and I have a 1, and I have a 2. But I also happen to have a 0 right here. Oh, I should probably not do that. I should probably do a 0. Okay. Now, in this instance here, this is the second part of the rule where it says zeros contained between non-zero digits are significant. So in this case here, this 0 is significant as well because it's in between two non-zero digits, the 1 and the 2. So when I go to record the number of significant figures that this number has here, I would say it has 4 sig figs. Okay. Now, that's the first rule. Second rule says leading zeros don't count. Sometimes I'll say out loud, leading zeros are never heroes, because that's kind of how I remember it. So zeros in the beginning of a number are not significant. So these zeros right here, all of those zeros are not significant, whereas the 3 and the 4 are significant because, well, they were they're non-zero digits. But that doesn't mean that those leading zeros don't matter or they don't count. What that simply means is that those leading zeros are holding place, but they're not part of being significant in terms of a measured number. So in this instance here, if I was going to identify the number of significant figures this had, it would just be simply the 3 and the 4. So it would be 2 sig figs. Okay. And then so we're going to do one more example over here. I do see that I have a few zeros at the beginning of the number here. So I have this 0 here, that 0 there, and then I have another 0 in the middle of the number. But I also have the 1 and the 2 and the 2. Okay, so I know that the 1, the 2, and the 2 are significant because they're non-zero digits. So I have at least 3 significant figures here. But the zeros at the beginning of the number are not significant. So I'm going to I'm going to put an X there because I don't want those to confuse me. So these two here are going to be not significant. Okay, so my final answer here is going to have, I should talk about the 0 in between the 2 and the 2. Now that one is significant because it's sandwiched in between two non-zero digits. So I would say that this one here also has 4 significant figures. Okay. And then the next part about this is going to be what we do with zeros at the end of a number. So trailing zeros only are significant. So let's see, trailing zeros or zeros at the end of a number are only significant if they're after a decimal or if they're trapped by a decimal. So let's take a look here. So here's my decimal point right there. So zeros that come after a decimal at the end of a number are significant. But zeros at the beginning of a number after, like up above, are not significant. So the 0 here, not significant. The 0 here, not significant. But these zeros here are significant because they're at the end of a number after a decimal. And so the 2 and the 1 are also significant. So all 4 of these are significant. So this is going to have 4 sig figs. Okay. Moving over to the right-hand side there, 14.56000, because those zeros are at the end of a number and after a decimal, these zeros are significant and they do matter in terms of the number of significant figures. So the 1, the 4, the 5, the 6, and the 0, 0, 0. So that tells me that this particular number has, let's see, 3, 5, 6, 7. Did I do that right? 1, 2, 3, 4. Yep, 7. So this one has 7 sig figs. Now, these other two examples down here are important because they're trying to illustrate the difference between a decimal being present with zeros at the end of a number or a decimal or not a decimal not being present. So with 3,400, right, I have no decimal, and that decimal is, and the lack of the decimal means these are like free. So they're out there for anyone to play with, and so they're not significant. So these, the 3 and the 4, are significant. So this number has 2 sig figs. Okay. But the decimal at the end of 33,400 right here is trapping those zeros in there into the number itself. So these zeros are significant. And so this number has 3, 4, 0, 0. It has 4 total sig figs. So this number has 4 significant figures. Now, those rules sometimes are difficult to remember. And so what I've done, or what I've taught in the past, is that we have some cheat codes to make this a little bit easier for us. So here's how I look at it. If the number has a decimal, so if there's a decimal present in the number anywhere, we're going to draw an arrow to the right, pointing to the right. Okay? And until we run into a non-zero digit. And then every number, including that non-zero digit and after, is significant. So I'm going to show you an example. So I here have 0.000325. And I could go back up and figure this out based on the rules up above. But if I just draw an arrow until I run into the 3, which is a non-zero digit, that means this is significant, this is significant, this is significant. So this number has 3 sig figs. And so I see a number off to the right here, 433,981,000.000. And again, there is that decimal point, right? So I see my decimal point is present. So this one right here. And I'm going to draw an arrow to the right until I hit a non-zero digit, which in this case is 4. So now that means everything after this arrow to the right is significant. So the 4, the 3, the 9, the 8, the 1, the 0, the 0, the 0. So this number has 9 sig figs. Now, there's another cheat code to this, and it has to do with if there is not a decimal. And so if there's no decimal present, we will draw an arrow to the left, pointing to the left, and every number, I made a mistake here. This should be left. Okay. And every number to the left of the arrow is significant. So here I have 2,500 with no decimal. So I'm going to draw an arrow coming in from the left, and I run into the non-zero digit 2,500. So that tells me that the 2 and the 5 are significant. So this number has 2 sig figs. Now 25 over here does not have a decimal, and there are no zeros, so that's kind of easy. So anything that's not a zero is significant. But just for sake of argument, I'm going to draw an arrow going this way, and I'm going to count. And in this case, I see that I have a 2 and 5. So that tells me this number has 2 sig figs. Now, you're going to hear me say this often, and one of the things you're going to hear me say often is that in chemistry, there's like exceptions to every rule. So there's two exceptions to these sig fig rules, and they're kind of simple to think about. So one of the exceptions is that if you have an exact number or a counting number, that number that is going to have infinite significant figures. So if I went to Taco Bell and I purchased 10 tacos for myself, this number here, the 10, even with a decimal point or without a decimal point, is going to have infinite sig figs. Okay. If we count something like the number of students in this class, let's say I counted and there was like 22 students in the class, and if there's 22 students in the class, because I counted it, it's a statement of fact, I now have infinite sig figs here. So this is also going to have infinite significant figures, and that's going to be important later. Relationships, or something we call conversion factor, something we'll talk about coming up. So 1 foot is the same distance as 12 inches, statement of fact. So that tells me that we have infinite sig figs also, because there's nothing to argue about there. Sig figs. Okay. And then another example would be 100 centigrams is equal to 1 gram. Also a measurement that is something we use as a conversion factor. And so those have infinite sig figs as well. So now we're going to go here and we're going to take a look at a little bit of practice. So if you weren't, so as you are following along, what I would really like you to do is take a few moments and pause the video and try to identify the number of sig figs. And just as a sample example practice problem here, I'm going to go ahead and do the first one, and then give you some time. So 1.20, I see it's got a decimal. So I'm going to draw an arrow coming in from the right and like this, and I'm going to count all of the digits after that arrow. So it's 1, 2, 3. So this number has 3 sig figs. Okay, so do me a favor, pause the video, work through the remaining 9 of these, and then we'll come back and go from there and see how things go. So I'm going to pause my video here and we'll check it. Okay, welcome back. Check your answers, see how you did. The major difference between how I determined significant figures here was that if there was a decimal, I drew that answer the arrow coming in from the right. And as a result of that, everything after the first non-zero digit was significant. So that's how I got 3 sig figs for the first one. For 500 with a decimal point, I got 3. And for the 0.0571, I got 5. For 1.00, I got 3. 4.05 or 405.8, I got 4. 0.047 and 0.0010 both got 2. The ones where I drew the arrow coming in from the right to the left, pointing to the left, they had no decimal point, so that's why 500 got 1 sig fig, 4 got 1 sig fig, and 2 got, or 610 got 1 sig fig as well. So that is the lesson on significant figures and how to identify them. And then if you have any questions, make sure you touch base with me. Otherwise, I will talk to you soon about how